911, what is your emergency?
Hi, I just went around a corner and I came across this accident. It's a van with kids, a dog, and it looks like the driver was injured.
Can you provide me with some more detail?
Well, it looks like the van hit a pole. Gosh, it looks like there's wires down over the car, and I don't know, but it's dangerous.
Okay, we'll dispatch EMS right away.
Choptank Electric is Tab.
Hi, this is the County 911 Center.
Yes, sir.
We received a call for an accident with wires down, with people trapped in the vehicle.
Okay, what's the address?
It's the intersection of Route 231 and Brooks Corner Road.
All right, the intersection of Route 231 and Brooks Corner Road?
Yes, and there are people trapped in the vehicle with the wires on the vehicle.
Okay, we'll get somebody out there right away.
All right, thank you.
Thank you. Bye-bye.
My name's Nick Noon. I'm a journeyman lineman with Choptank Electric Cooperative. This is Nathan Smith, chief lineman with Choptank. As you just heard, a 911 call come in regarding an accident with wires down. Not only do vehicle accidents cause wires down, but also storms, high winds, and trees cause wires down also. This video is to teach the first responders in the community the dangers and precautions of wires being down. In this scene, we're going to demonstrate safety. Here we have a vehicle accident. We're going to demonstrate the safeties of the vehicle accident, wires down. We have two different scenarios here. One is our overhead lines that we have that have 7,200 volts, and the second is our underground that we also have that also has 7,200 volts. Both of these are just as dangerous. Here we have one that a cable that's underneath the vehicle, and the other one we have laying on top of the vehicle. In both circumstances, this vehicle is considered hot and at 7,200 volts until a lineman gets there and deems it safe and has it grounded. The procedures, it would take a while for us to get there, but the first steps is if you roll up on this and you see this or you're in this accident, you'd call 911 and they'd put the procedures in place on who gets called and how we get there. So naturally, your emergency responders are going to be the first ones on scene, and their natural instinct is to go and help somebody, and they're going to want to run up to this vehicle. Well, today, that's why we're here, to tell you not to do that. Your step potential is 35 feet around this vehicle is also could be energized, and you want to stay away from the vehicle. And if the car is not on fire, there's no danger, the person inside the vehicle needs to stay in the vehicle until we get there and deem it safe. Because she's fine in there the way she is, and that's the way we want to keep it. Nobody else gets hurt. We don't want you to get hurt trying to save her. So when we get there, it's going to take us a while to do our thing because we're going to be to adjacent poles, having to ground everything and ground. If it's underground, there's different transformers downline that we would have to go to and do different steps. We have to open, test, and ground and tag our line for it to be considered dead to our standards. And then we'll come and help you take the stuff off the car so you can get in there and help them. Next, we're going to demonstrate how to get somebody out of the vehicle if they're in immediate danger inside the vehicle and have to come out. So at this time, you can see that the vehicle is on fire. So we're going to want to get her out of the vehicle. If we haven't been there to get the line de-energized and you need to get her out, these are the steps that we're going to take. At no time do we want her to touch the car and the ground at the same time, because that makes her a potential to ground. So we're going to get her to open the door and stand on the ledge of the car without touching the ground, without touching anything else except for the vehicle. She's going to cross her arms across her chest, and she's going to hop to the ground, keeping her feet close together, touching. Now she doesn't want to touch the car at all, and then she's going to slowly shuffle herself, keeping her feet together all the way 35 feet out until she's in a safe spot to be able to walk and get away from the vehicle without having any step potential. The reason why her feet are staying together is because if she takes her feet and takes them apart from each other, she becomes that potential for electric to go through her and out the other foot. Now, naturally, I wouldn't be this close to the vehicle. I'd be 35 feet, but for demonstration purposes, that's why I'm here where I'm at.
As you've just seen with the accident scene that Nick demonstrated, that's one of many situations that we may come across that cause lines to come down. Tree limbs fall, storms, all those things can actually bring the power lines to the ground. And at this time, we've got to assume that the power lines are energized for safety. What we're going to demonstrate to you in this scene is going to be, scenario will be a tree branch leaning against the line. So just always remember, as Nick goes up here and touches this tree branch to the line, you can see the electricity will start to flow through the branch and it's going to ground. So at the same time, you need to remember that anytime a tree branch or tree is touching the utility line, what happens is the voltage is trying to go to ground, and then the ground around the tree also becomes energized. So you may not even have to step foot close to the tree. The ground becomes energized. You can get electrocuted through step potential by walking up close to that tree. As you see, the tree branch is starting to smoke. Depending on conditions, you'll see the electricity start flowing through it. You can see the fire starting. The electricity is actually going through that branch and it's going to ground. There's a path. This scenario here, we have 7,200 volts coming across this top line. Nick's holding this with a fiberglass insulated stick. What he's going to show you, he's going to draw the electricity out of the line. You're going to see an arc. And that right there, that's 7,200 volts, very deadly. So anytime working on utility lines, we always have to make sure that the line has been opened up. It's a set of rules that we have to go by. We open, and then we test, and then we ground the line, and we have to put a tag on it to let other linemen or utility workers know that there's, for some reason or another, this line has been de-energized by a professional lineman. Nick's going to open this fuse door that's feeding this center phase on our demonstration trailer. Then open it up. Okay, this is the first step in the process that we have to go through. We've just opened the line, made a visual opening point. Our second step is to test. At this point, we're going to use this audio tool it's audio and visual aid so we can tell whether or not the line has been energized or de-energized. Right now, we're verifying that the line is still energized. Now that we've created a visual opening point and tested it, we can apply a ground on the line that will assure us that we're protected. All right, as Nick applies this overhead ground, after this has been done, then we can actually touch the line with our leather gloves, but only until that time. Now that our overhead ground has been installed, the next step in our process is we have to install a tag at our opening point. What this tag is doing, it's reassuring us that anytime another lineman would come by onto the scene, he can see that there's been a visual opening point created and that for some reason or another there's someone working on this line. And we know not to try to re-energize to heat up a cable that somebody could potentially be working on, or there could be an accident that's caused some reason for the public to be in danger. Okay, now that we've gone through this process, you can see sometimes it takes a while for the lineman to show up on the scene and deem that the electric line has been de-energized. Just because we're not there doesn't mean that we haven't done anything. You can see that this may be spans poles away from the actual scene. It could take a little bit of time to get this established. So what we're going to do now, we're going to go ahead and show you the process of re-energizing a line. We're not allowed to close an opening point back in until a tag has been removed, because then we know now that the line, in the process, the line has the ability to come energized with no harm to any of our workmen or the public. Nick's going to now take the ground off. This same process applies for overhead and underground. We have special grounds for underground that are set up exactly for underground scenarios. And now that we've removed our ground, we can reestablish. We can close back in on our switch, re-energizing the line. Okay, Nick, you can. Nick just energized this outside phase, heating up 7,200 volts to the phase closest to us. And we know that because down here on the ground we have a meter set up with a light bulb that you can see that those wires are actually energizing this light bulb. This whole process is being done off of 120 volt backfeed, so that's another thing to keep in mind, is that any generators hooked up incorrectly can be hazardous to linemen. At this time, we're going to go ahead and demonstrate to you what happens when a fuse door opens up. As Nick closes this in, we have another light bulb here, down here on the trailer as a display that shows us that now the B phase or center phase on our trailer has been energized. As linemen, we've been trained. We've been through a 3-year apprenticeship program, and we are not allowed to touch anything. You see all the equipment that we have on. We have rubber gloves, we have sleeves, we have FR clothing, we have EH rated boots, all these to ensure our safety. We have ANSI rated safety glasses, hard hats. All this is to ensure our safety. So at no time does that any public person in the public would want to go to a down utility line and touch it, because you can see as trained professionals, this is what we have to wear, and these are the processes that we have to go through, and it's to ensure our safety. The last thing you want to do when trying to go up to a scene is to endanger yourself and become a victim as well.
We made this awareness video to educate and inform you. We want to share this video with our community, fire, EMS, police, and our schools, and also tow truck drivers, to show the dangers of down power wires. Choptank Electric personnel are available to give a presentation as well as show this video to your group. Just give us a call. At Choptank Electric, we're doing our part to keep our members and our community safe every day.